This question is from GATE 2014 Mechanical Engineering paper, set 2, question number 33. Consider a flywheel whose mass M is distributed almost equally between a heavy ring-like rim of radius R and a concentric disc-like feature of radius R by 2. Other parts of the flywheel, such as spokes, etc., have negligible mass. The best approximation for alpha if the moment of inertia of the flywheel about its axis of rotation is expressed as alpha mr square is dash. So the flywheel looks something like this. This is the outer ring of radius R and this is the inner having radius R by 2, capital R by 2. And mass is equally distributed between the two. So if we have capital M, that is given is the total mass of the flywheel. This has m by 2 mass and this has, so we can write here total mass of the flywheel is capital L. Mass of the rim will be m by 2. Mass of the disc will be m by 2. And moment of inertia I is given to be alpha m r square. We need to find the value of alpha. That means we need to find the total moment of inertia of this flywheel as a combination of this rim and disc, and then whatever is the coefficient of mr square will be the value of alpha and will be the final answer. So we can write moment of inertia of the flywheel will be equal to, so for the outer ring we simply know that moment of inertia is mass into r square. For this I is its mass into its radius square, and small m here will be capital M by 2 because that's the mass of the outer ring into r square. This is for the outer part, plus for the inner one, as per the standard formula for disc, moment of inertia is mass of the disc into its radius square by 2. Both these mass moment of inertia we have taken about axis that is perpendicular to the plane of flywheel, because about that axis the rotation will take place for the flywheel. So both of these are about an axis perpendicular to the plane of flywheel. So if we add this, we have mass is m by 2, radius is capital R by 2 whole square divided by 2 again. Now let's add this and find out alpha. So we have I for flywheel will be equal to, this is mr square by 2 and this will be m by 2 into I square by 4. So it will be mr square by 8 by 2. So we have mr square by 16. Adding these two, we have 8 plus 1 9 mr square by 16, and 9 by 16 when calculated in digital calculator gives us 0.5625 mr square. So we have the value of alpha here by comparing it to this given thing, 0.5625. Let's go back and fill in the answer. If the moment of inertia of flywheel about its axis of rotation it is given, we have to find out moment of inertia about axis of rotation. That's what we did. Is expressed as 0.5625. Unless otherwise mentioned, you should always take the axis of rotation only, because that is the motion of a flywheel. To learn more about flywheel, you can refer to the NPTEL video lecture 25, theory regarding moment of inertia of a flywheel, from the course Experimental Physics 1. This course is by Professor Amal Kumar Das. He is from Department of Physics, IIT Kharagpur. I hope the solution will help you clear your doubt. Thank you.